Hello friends, hope you are safe and sound. Have you ever wondered how the workload get deployed in the cloud infrastructure in just a matter of minutes and the workloads on your on-prem infrastructure takes time to implement? What if we can have the same capability of getting the workloads implemented in few minutes with the right set of policies in your on-prem data center? Welcome to All on Tech. This is Nityanand here, and in today's video we will focus on how we can have software defined data center on-prem. In traditional data center, as we add more number of switches in the network, the complexity increases. We have to configure and manage those network devices manually, which may involve human error. What if we can have a software defined approach using which the configuration can be pushed from a controller to all the network devices? In traditional network design, you may have two-tier architecture based on core and access layers. Access switches or top of the rack switches will need to be connected to core switches using the two links, and to avoid the loops, the network administrator has to configure spanning tree protocol. But this introduces a major bottleneck, as you are only able to use one link from your access switches to the core switches, and other link gets blocked by spanning tree. What if we can configure the links in such a way that we can utilize all available paths between the core and access switches? With traditional VLAN based approach, you cannot scale beyond 4996 VLANs. What if we can add the scalability in the data center to go beyond this limit? Also, you may be using different workloads like bare metal, VMware, Hyper-V, and containers, and different teams may be deploying and managing policies for the infrastructure. What if we could have a single policy engine for the data center for different type of workloads to get those deployed efficiently? IT teams regularly need to plan downtime for the firmware upgrade of the infrastructure. What if we can have a solution which can help in reducing the overall downtime in the data center because of the firmware upgrades? The layer 4 to layer 7 services like firewall and load balancers are managed separately in data centers. What if we could have a traffic redirection policy which can bring automation? Here comes application centric infrastructure or ACI, which can help us in solving all these issues and bring agility in the data center. We'll take a look at different components and architecture of ACI. ACI introduces a spine and leaf design based on class architecture. This is the two-tier design wherein each leaf switch gets connected to each spine switch. Leaf switches cannot get connected to another leaf switch, and spine switch cannot get connected to another spine switch. Workloads will only get connected to the leaf switches. The advantage of this design is every endpoint connected to the leaf switches will be able to reach to other endpoint connected to other leaf switches in a single hop. In case you need to expand the number of servers in your data center, you just have to add leaf switches, and these new leaf switches will need to be connected to each spine switch. In case if you would like to increase the throughput within the spine and leaf switches, you just have to connect more links between the spine and leaf switches. And you can also introduce new spine in the network and connect the leaf switches to the new spine switch. Using the ACI, we can create fabric between the leaf and spine switches. When we create a fabric, we can have an overlay network on your leaf and spine architecture. ACI uses ISS as an underlay protocol and VXLAN as an overlay protocol. As layer 3E protocol is configured in underlay, we will be able to use all the available links and spanning tree will not be required. Also, the fabric will provide one large non-blocking switch where you can connect endpoint to any of the leaf switch and can define the policy for that endpoint. In traditional architecture, we used to configure gateway on the core switches. In the ACI fabric, the gateway is configured on the leaf switches and it is called Anycast gateway. With this, you can move virtual machine and containers within your data center without worrying about the network policy configuration, as the network gateway moves along with the virtual machine or containers within the ACI fabric. Does this sound complex to you? So here is the good news. You don't have to worry about the layer 3 and VXLAN configuration at all. With the help of AP controller, which acts as a policy engine, the leaf and spine switches will be discovered and the required configuration will be pushed on these leaf switches and overlay will also be configured. You may start with few spine and leaf switches and expand to hundreds of switches inside your data center. And all this will be managed through this Epic server dashboard. Another advantage ACI brings is logical constructs, using which you can bring agility and plan granular segmentation with zero trust approach. The highest tier in logical construct is tenant. Let's understand how tenant is useful. You can plan multiple tenants inside your data center, like one tenant can be used for production and other tenant can be used for UAT. In case your organization has multiple subsidiaries and you would like to have complete isolation for the workloads of these subsidiaries, then you can plan multiple tenants for each subsidiary. This can save a lot of cost as you can consolidate the network infra for all these subsidiaries. Within tenant, you can plan for one or multiple VRFs. VRF is nothing but a private network or IP address space. Under VRFs, you can plan bridge domains. Bridge domains can contain multiple subnets under them, and it is similar to layer 2 broadcast domain. Under these bridge domains, we can plan EPGs or endpoint groups. In endpoint groups, you can have endpoints with similar characteristics. For an example, you can group all web servers in first EPG, all web servers in second EPG, and database servers in third EPG. With EPGs, you can have granular control over which endpoint can communicate to which other endpoint inside your data center. Based on your needs, you can either allow or block the communication within the different EPGs using the contracts. So here you can define a policy that servers in web EPG should only be able to communicate to servers in app EPG, and servers in app EPG should only be able to communicate to servers in database EPG. As you have not defined any policy for servers in web EPG to communicate to database EPG, they will not be able to communicate with servers in database EPG. This helps in simplifying the segmentation versus the old method of using the access control list, which expands as the number of workloads increase inside your data center. You can also use VM attributes like virtual machine name, operating system on that virtual machine to classify and segment the servers. This is really useful in case you would like to only isolate Windows-based servers in case any vulnerability is affecting only certain Windows servers, or you would like to isolate servers to protect against ransomware attacks so that it does not spread within your data center. Traditionally, firewalls and load balancers are configured individually, but with ACI, you get an option to redirect traffic through these firewalls and load balancers using service graph, which helps in simplifying operations. Also, many organizations use VMware, Hyper-V or Kubernetes in their environment, and the VM administrators have to manage the policies pertaining to the virtualization solution. ACI gives you an option to get these solutions integrated, which allows the virtual machine administrator to configure the network related policies on the fly when they create a virtual machine without any dependency on the network team. IT teams plan downtime to upgrade the firmware on the network devices. With ACI Fabric, you get an option to upgrade the spine and leaf switches in a sequential manner, which helps in almost zero downtime for the upgradation of your infrastructure. Just to summarize, using application-centric infrastructure, you can bring agility in your data center and simplify the overall operations. Bring zero trust approach in data center for all your workloads and reduce the required downtime for the firmware upgrades. Hope you found this video useful. Do share the video and hit subscribe button to get more such videos. Thank you.